Okay, welcome back to our next lesson. This lesson is actually on page 14 in your notes, and this is on domain and range once again. Now, we've spoken already about domain and range. Domain stands for all the possible values of the independent variable. Usually, in most functions, that would be your x values. The range refers to all of the possible values of the dependent variable, and for the majority of cases, that would be your y. Okay. Now, when we looked at it before, though, we were looking at domain and range if we were given the graphs. In this lesson, we're going to be looking at the domain and the range if we're given the actual function itself. And that's going to take a little bit of careful consideration, a little bit of careful thought. We're going to be looking at basically two places, two types of functions where problems could exist. One of them, and remember one thing you're not allowed to do in mathematics, is divide by 0. All right. So if you have a simple function such as y equals, let's just say 1 over x. All right. Now you can plug in pretty much any number you want there for x with the exception of 0 because the denominator is not allowed to be 0. So your domain in this case would be values of x such that, and the way you can say that it can be anything except 0 is to write x is not allowed to equal 0, x cannot equal 0, but it can be anything else, any other real number. So there would be our domain in this case right there. Now for a simple function like that, what we call a rational function, if there are x's in the denominator, but no x's in the numerator, the range is always the same thing. The range is going to be, you can put, if you put values of x in there, you can get back almost every number that there is except 0 again. All right, so you cannot get that function to equal 0. It can equal anything else, but it cannot equal 0. So all of the rational functions that we're going to see here today, there are no variables in the numerator. That would be a different situation if there were. And we'll look at those cases a little more closely in unit number 6. So the other problem case that we're going to look at would be square roots. And I know back in unit number 1, we were taking square roots of negative numbers. Yes, getting imaginary things, imaginary numbers. But in this unit, we're only considering real numbers. So for this topic here, for this unit, we're not supposed to put negative numbers in under square root signs. Not if we want real values back, and that's what we do want back. So let's have a look at some of these examples that are here. And let's carefully see what we have. Okay, the first one, example number 4, y equals x squared subtract 5. Now, you have to ask yourself very carefully. You want the domain, you see, and you want the range. The domain is all the x values, and the range is all the y values that you can get back. Well, if you graph this, you'd get a parabola. Well, we don't have the graph, not in front of us anyway. You could draw the graph or sketch the graph and get the domain and the range from that. But the key to getting the domain here would be to just ask yourself, here's your x, you see, there's your x. What numbers are you allowed to put in there for x? All right, can you put in positives? Well, yes. Can you put in 0? Yes. Can you put in negative numbers? Well, yes again. You can put in decimals, fractions. You can put in anything you want. Well, that means that your domain, I'll just write a D here for domain. Your domain can be anything. Any real number that there is. Okay? You're allowed to put that in. There's nothing stopping you, in other words. Now, what about the range? What about the range for this function? And remember now, that would be our y values, the values of the dependent variable. Well, you have to consider what happens when you take all of those different x values and you put them in x squared. All right? You can put in the negative numbers, you can put in positive numbers, you can put in 0. But when you square something, it makes it positive, doesn't it? When you square something. In fact, the smallest that you can make x squared is when you put 0 in for x. And that would become 0 squared. Okay? So think of this x squared part, the smallest it can get is 0. It can get larger, but the smallest it can get is 0. So your y values now would be 0 or above minus 5. All right, now think about that. How small can y get? Well, the smallest that the x squared can get is 0, but you're subtracting 5 from that in the function. Well, that means that y can actually go down to negative 5. It can be bigger, but that's as small as it can get. So your y in that case would be greater than or equal to negative 5, and it can be any real number in that range. That one was not too bad, but you very carefully had to consider that, okay? Let's look at B. We have y is equal to the square root of x. Well, remember now, we just said a moment ago that we're not going to be considering imaginary numbers in this chapter, which means that your domain, what numbers are you allowed to put in there for x? Well, you can put in any positive number you like, and yes, you can put in 0, because the square root of 0 is 0. That's nothing wrong with that, but you can't put in anything less than 0. So the restriction would be x such that x is greater than or equal to 0. X belongs to the real numbers. All right? Now, what about the range? What y values will you get back? Well, if you did put in a 0 for x, you'd get back a 0 for y, right? But this symbol right there, that's what we call the principal square root. It only means the positive square root. That's the only thing you can get back from that, never a negative. If that's the case, then y can be any positive number, yes. It can get down as low as 0, but it will never be anything less than 0. So that tells you that your range, values of y, such that y is greater than or equal to 0, y belongs to the real numbers. Okay? What if it was a little more complicated than that? Let me show you. What do I mean by that? Let me give you a different example for square roots. Now I erase all this. Let me erase all that. I haven't found a simple way to erase these things yet. I'm sure there must be, but I just haven't found it yet. Okay, so what I mean by another example. What if I give you this? Y is equal to the square root of 3x plus 1. All right? Now what's your domain? Now what's your range? Well, all you need to remember is that the piece that's in under the square root sign, that 3x plus 1, it can't be negative. All right? It can get down to 0, or it can be above that. So what you're really doing is you're solving this inequality right here. 3x plus 1, that has to be greater than or equal to 0. Now you solve that inequality exactly the same way you'd solve an equation. You can bring that negative or 1 to the other side, and it becomes a negative 1. You can divide them by 3, and look at that. There's your domain. Now be careful with inequalities, though. Remember that if you multiply or divide both sides of an inequality by a negative number, that sign switches around. All right? So there's your domain, everyone. There's your domain right there. And in fact, you could write that the domain is, ta-da, values of x such that x is greater than or equal to negative 1/3. X belongs to the real numbers. Okay? And the range for that is exactly the same as the range for the other square root function. Y such that y must be greater than or equal to 0. Y belongs to the real numbers. Okay? So that would be your domain and your range there. Now the third case that they show us, part C, look at that. There's your rational function. You can see an x in the denominator, but there is no x in the numerator. That's good. That means that we know what the range is going to be automatically. Okay? The range there is going to be the same as the range for the same one I mentioned a moment ago. The range is going to be everything except 0. Y can be anything except 0. Okay? And in fact, getting the domain here is not too bad either. Here we have 2x in the denominator. Just remember that the 2x, whatever the denominator is, it's not allowed to equal 0. So just solve that equation right there. kind of like an inequation, isn't it? Divide both sides by 2, and you get that x, 0 divided by 2, well, that's just 0 again. So x is not allowed to equal 0 there. That's your domain. Values of x such that x is not allowed to equal 0. X, that's a 0 there. X is an element of the real numbers. And the range, of course, I just mentioned a moment ago, that's going to be everything except 0 as well. It's always everything except 0 for these types of rational functions, okay? So there's your domain. That's a 0. Okay, so that's your domain and range for part C. Now, even if it was more complicated, like if you had y equals 1 over 4x minus 7. I know the range is just everything except 0, but what about the domain? Well, take this denominator, 4x minus 7. It's like a little test you're doing, see? That's not allowed to equal 0. Now, you get that x by itself. So 4x is not allowed to equal 7. You bring your 7 over. Divide both sides by 4. And look at that. There's your domain. Everything except 7 over 4. So it's a very simple concept. Now the examples down below, I'm going to leave those for you to try. You better be careful with the a, though, the log function. Now you did logarithms back in Math 1700 as well, right? Now remember that when you're taking logarithms, there's certain numbers you're not allowed to take logarithms of. So that would be, for example, negative numbers. If you try to take the log of -5, you'd get an error message back. But you're also not allowed to take the logarithm of 0. So that tells me that your domain is going to be values of x such that, now it can't be negative and it can't be 0. So that would be strictly greater than 0. X is an element of the real numbers. And something else about logarithms, if you think carefully, when you did logarithms in 1700, what kind of numbers did you get back when you take logs? Well, if you take the logarithm of a fairly big number, you're going to get a positive value back. If you take the log of 1, you're going to get a 0 back. And if you take the log of a number between 0 and 1, like the log of 0.5, you get a negative number back. Well, that means, everybody, that you get everything back. The range is everything. Okay? And the other ones I'll leave for you to try. The exponential, now think carefully about that. What are you allowed to put in there for x? Well, I think you're allowed to put in anything. What values will you get back? Well, I'll tell you, you won't get any negatives back. There is one other one I want to look at, and that's C right here. I think I should do that one with you, because that one is kind of a special case. All right, I'll just do this one very quickly. What is the domain and what is the range from that graph there? Okay, well remember, domain is the same thing as saying how far left, how far right does that graph go? And the range is the same thing as saying, well, how far up, how far down does that graph go? Well, here's your domain. Let me get my marker. I've only got a minute and a half left, so I better hurry this up. Your domain would be values of x such that, now look carefully at your x's. You can see that the smallest it gets is 0, but the biggest it gets is 7. So all the x values between 0 and 7. And here's the easiest way to write that down. Write the 0 first, and then less than or equal to, and then write your x, and then less than or equal to again, and then the bigger number is 7. Now, and it's all real numbers in that range. You see that? So any x value between and including 0 and 7 are on that graph. And for the range, okay, that's your y values. How far up, how far down? Well, it looks to me like it goes up as far as 4. That's the highest point there, you see? And it goes all the way down. There's your lowest point. It goes down to -2. So the smallest value is -2, less than or equal to y, less than or equal to, and the highest it gets is 4. Yep. Y belongs to the real numbers. All right, so I'll stop there. You try the other ones, please. We're almost out of time. Check your answers on D2L, the solutions. If you have any problems, any trouble, you let me know. Okay, pop me an email. All right, that's it for this lesson. Bye-bye.